In this video, we're going to show you how you can generate 3D toolpaths in an external program and import those into VCarve Pro to complement the 2D and 2.5D toolpaths that can be calculated in the software itself. For our specific example, we're going to use a program called Vectric 3D Machinist to generate the 3D toolpaths. This is a program which is offered through the Vectric 3D website as a solution to machine their 3D clip art models. It is developed by Vectric and is offered for free because it will only cut the Vectric 3D artwork. It's important to note that if you wanted to work with non-Vectric 3D models, or you wanted to work with data that was created in another 3D design program, then you could use Vectric's Cut 3D software to generate the toolpaths. If you're interested in that, then it would be worth going to the Vectric website and downloading the trial version of Cut 3D to see exactly what it can do. In this video, we're going to start in VCarve Pro and we're going to show you how to do the 2D vector layout for the sign that you can see on the screen. Part of that layout will be to draw the circular area that our carving is going to fit in, which is going to define its size and position. Then we're going to go into the 3D Machinist software, we're going to calculate our 3D toolpath based on that size, and then we're going to save that and import it back into VCarve Pro, and finish by creating the V-Carve toolpath for the lettering and the profiling toolpath to cut the sign out. Let's begin by starting a new copy of the software. For this example, we're going to start with one of the pre-created pieces of vector clip art that's supplied with the software. Now click on the icon to open an existing file, and in this case I've already moved the file that we're going to use into our project folder. So I'm going to click on the name of the file, panel44.crv, and I'm going to hit open. Now we can see that vector outline has now been loaded into the software. Now this is at a pre-created size, so the first thing that I need to do is change the size of my job and the size of the part within it to match the parameters I want to use for this particular project. So first, let's change the job size. So we'll come over, click on the icon to set job dimensions and origin. And in this case, what I'm going to do is edit this so that the job is 21 inches wide and 18 inches high. Once we've entered those values, I want to check some of the other values that we've got set up for the job. In this case, I would like to make our little sign out of 3/4 inch material, 0.75. And while we're drawing this, I'm going to leave the datum set in the center here, but I may change that when we come to start calculating the toolpaths. I'm going to work in inches, I'm going to come down and hit OK. Next we're going to select the vector outline from the 2D view, and I'm going to come over and click on the icon to set the selected object size. So we're going to type in new values for the size of this. I'd like to keep the anchor point in the middle here, so make sure that this is selected. I'm going to make sure link XY are both checked, and then I'm going to adjust the width to be 18 inches and hit apply, and with link XY checked that will automatically scale my Y value or the height of the part as well. Once I'm happy with that, I can hit close. Next we're going to take the outline, which we still have selected here, and create a couple of offsets to build all of the vectors we'll need to machine our border and create a cutout shape for our sign. So I'll say make sure that vector is still selected. I can see that it is. I'm going to come down and click on the offset selected vectors icon, and within here I'm going to select the option to offset outwards. I'm going to type in first the distance of 0.2 inches. I'm going to make sure I have the option checked to create sharp offset corners, and the option here checked to select the new vector, the one that we create when we offset the one that's currently selected. I'm going to click on the offset button after I've set all those values. You can see that's made a small offset of our original vector, selecting the new one. Now I'm just going to type in a value of 0.55 and hit offset, and there again we've created another new offset vector. Notice with the create sharp corners selected here that it's maintained these corners without rounding them off when the offset was done. I'm happy with that. I can hit the close button. So there we've created two vectors here which are going to represent a groove that we're going to V-carve to add some decoration to our border, and this will represent our overall shape that we're going to cut out. Next, I want to create a vector that will represent the area where we're going to have our 3D carving. In this case, I know the carving that I want to make is circular, and I want to place it so that it's in the center of the arc of our original border line here. Now the software should automatically pick up the center point of an arc with the snapping of the cursor, so I should be able to just come across, click on the icon to draw circle. I'm going to enter a diameter for our circle of 7.5 inches, and I'm going to bring the cursor over into the 2D view and move it so that it's about where I think the center of that arc is, and you can see there the software automatically snapping. So I've got the crosshairs. If I move it off, that changes. If I move it back, I get the crosshairs, and then if I just click, it'll create a circle based on the diameter I've put there at the position where we click the mouse, which we know is snapped to the center point of this arc. Again, when I'm happy with that, I can hit the close button. And the last thing we need to create as part of our 2D vector layout is the text. I'm going to come down to our draw text icon. In this case, I'm going to type in the text, which is going to say Fleur de Lis on the first line, and then hit the enter key on the keyboard, and we'll type B and B, short for bed and breakfast. The font I'm going to use is called Palatino Linotype. If you don't have that, you could select a different font. Just click on the down arrow and maybe choose something similar to that. Times New Roman or something like that would also work. I'm going to check to make the text bold. I'm going to set the text alignment in the center, the height of the text to be 2, and in this case I know where I want the anchor position for my text to be, so I'm going to enter x0, y minus 3.5. If I go ahead and hit apply now, we can see the text has been created based on all the settings I've entered in the create text form. I'm happy with the way that looks, so I'm going to hit the close button again. At this stage, we've finished our 2D layout and we're ready to start calculating our toolpaths. Now the first toolpath that I want to create is going to be to carve our 3D element that's going to fit into the circular area in our design. I can't calculate that type of 3D toolpath in VCarve Pro or Cut 2D, so I need to use an external program in order to generate that data, which I can then save and import into the program here. To generate our 3D toolpath, we could use Cut 3D, which is one of the other Vectric products. That process is actually dealt with in another tutorial video in a lot of detail. For this example though, we're going to use a free software program called VectorArt 3D Machinist. This is also written by Vectric, but it's supplied through the VectorArt 3D website. So I'm going to go ahead and just start a web browser now. And you can see into the address bar here, I've typed the URL www.vectorart3d.com. VectorArt 3D specialise in supplying 3D CNC ready clip art that can be downloaded from the website and used to generate toolpaths to run a CNC machine. This will work with many different software programs, including Vectric's Cut 3D and Aspire. But some people may not have access to specialised 3D software, or they may only need to do this occasionally. So VectorArt 3D supplies a program called VectorArt 3D Machinist. We can download this by going to this area here where it says free downloads and clicking on the link here for free 3D Machinist software. When I click on that, that'll take us to a page where we're able to enter our name, an email address, and the website will send us a link via email when we click on the button to send me the download link. As well as being able to get the software, you can also scroll down the page and you can see there is a selection of free models that you can download. These all come in the V3M file format, which is a special format specific to VectorArt 3D Machinist, Cut 3D and Aspire. For our example, the piece of clip art I'm going to use is one of the free sample models, and it's this dished version of the fleur-de-lis that you can see here. So I would simply click on that option, click on the download button, save that file onto my PC. I may need to unzip it, but then I would have that file and be ready to use it with the free software. In this case, we're not going to dwell on the process for the downloads and the setup of this. You can come to the VectorArt 3D website, read all about this, view their detailed video tutorials on how to use the software. Here what I'm going to do is start the software, load the file, and just very quickly show you how you would generate a 3D toolpath that we can then take and import into our original layout. So let's minimize the website. I'm going to imagine I've downloaded and installed VectorArt 3D Machinist, and I'm going to go ahead and start a copy of the software. Now, although VectorArt 3D Machinist is free, it's still a fully functional CAM package that will allow you to create roughing, finishing and cutout toolpaths on a 3D model. The limitation is it will only work with 3D models from VectorArt 3D. If you're looking to work with other 3D models, that's when you should take a look at Vectric's Cut 3D product that will allow you to read a lot more file formats from different websites and also from other design packages if you're working with a 3D CAD package. So as well as downloading and installing the software, let's also imagine we downloaded our free sample model, we've unzipped it. We can now click on the icon here to open VectorArt 3D model. And from the project folder, you'll see there is a file that I've renamed fleur-de-lis-b. The B is the VectorArt 3D indicator that it's a dished model, and I'm going to hit open. And there I can click the left mouse key in the window, rotate that around to see this 3D object that we've loaded into the software. Software is wizard based, it's very easy to use. In this case, I'm not going to give you a detailed explanation of everything in the software because there are other videos on the VectorArt 3D website that do cover that. I will point out at this initial stage that you load the model though, that it is possible to mirror it in X, in Y, or to rotate it 90 degrees clockwise or counterclockwise. I'm going to go ahead and hit the next button at the bottom of the first screen. And in the second stage here, we're going to set the dimensions of the part and its location. So here you can see the width is a little under 6 inches. If you remember, our circle was drawn at 7.5 inches, so I would like this to be 7.5. And if I leave these options checked, then that will automatically scale the height for me. For the depth, it's automatically scaled that to a little over 0.3 of an inch, so I think I'm just going to round that to 0.3 exactly. Date and position I'm going to leave set in the center at X0, Y0, and the material thickness and origin need to be set up exactly the same as the part that we created in the 2D layout, either in Cut 2D or VCarve Pro. So in this case, that was Z0 set to the top of the material and a thickness of 0.75 inches. Very, very important that these settings match the values that you set up in the 2D layout. Once I'm happy with these, I'm going to hit apply. One thing I didn't mention there is this position of the model in the material. In this case, because we're cutting a dished model, I want to make sure that the gap above is set to 0. That means the edges of our dish will be on the surface of the material. So again, make sure you've set all these values, hit apply, and then we're ready to hit next. The next option we have is if we'd like to create a roughing toolpath. What the roughing does on a 3D model is hog out the material with a larger tool, leaving a skin left that will be machined away with the smaller finishing tool. So really it's a way of relieving the stress that the finishing tool may have to go through when it cuts, taking away particularly deep areas of material. In the case of a dished model though, it's a little bit unusual in that the tool, the finishing tool, is going to start on the edge and then work its way across the model. So the first cut it makes is very, very shallow and therefore doesn't provide a lot of stress for the tool. After that, it's moving over a very small distance each time it makes a new cut, and so the tool is never overstressed. So in a job like this, where we don't have a particularly deep dished model, it's not particularly large, we can probably avoid the roughing stage. If you're not sure about this though, or you're cutting it in particularly hard material, or you have particularly small or fragile finish tooling, you would want to create a roughing toolpath. Here I'm not going to, so I'm not going to check this. I'm just going to come down, click on the next button, and now I'm going to create my finishing toolpath. I'm going to select from the tool database a 1/8 ball nose tool. So this is a finishing tool, 1/8 diameter. It's got a round end, and you can see that one of the most important parameters in here is the step over. This is the distance that the tool is going to move over between each pass it makes across the 3D model. We can then come in and set our feed rate and our plunge rate to appropriate values for the material you're using, and you need to make sure whatever values you choose for any machining that you calculate are safe for your particular setup, the tooling you're using, and the material you're planning to cut. Here I'm going to hit apply, OK. I can choose whether I want to raster, that's the direction of cut, along X, along Y, or at 45 degrees across the model, and I specify the distance above the material that I need the tool to lift out from if I want it to move fast to another position in the job and avoid things like clamps or other objects you may have holding the part down. Once I'm happy with these parameters, I can hit calculate, and the software will just take a few moments to go ahead and calculate our toolpath based on the tool we've selected and the parameters we've entered into the finishing toolpath form. Once it's done, you'll see the 3D view will update and it will display a whole bunch of blue lines. If I zoom in, which I'm doing by right mouse clicking and pushing the mouse away from me, you can see those lines basically follow the shape of the 3D part, and that's how we're going to generate our 3D object with the CNC, is by that round tool just going back and forward over the three-dimensional form that we imported. Now this can be a little tricky to see how that exactly is going to translate to the finished piece. So what we also have the option of is doing a preview on this, which we'll get to in a moment. First we need to hit the next button again. This now gives us an option to create a cutout toolpath. For a dished model like this, you typically wouldn't be cutting it out because that would run the tool around the outside of the circle. Normally that option is going to be used when you're cutting the A or the regular version of the file from VectorArt 3D, where you'll have machined away the three-dimensional object and then you actually want to follow the shape of the object itself to cut it out to create an applique or an onlay or something like that. So we're not going to use this option for this particular example. We're just going to click on the next button again, and now we get to the preview stage. See, because we didn't calculate a rough or a cutout toolpath, those are not available, but what I can do is click on the button here to preview the finishing toolpath that we calculated. So let's click on that button, and you can see the software will animate the shape and size of tool that we selected going along all those blue lines, or the toolpath that we calculated, and this is showing me exactly the part that I'm going to get were I to cut this on my CNC machine. This stage is very important. It lets me see two main things. The first one is how much detail I'm going to get in my part. This is a combination of the size that we've set the part to, the size of tool that we've chosen, and then how many areas that tool can fit into as it traverses back and forward across the 3D object in the software. The second thing it lets me see is how smooth a finish I'm going to get, and that's based on the size of the tool and that step over that we selected. In this case we've got a 10% step over, so you can see we're getting quite a nice smooth finish on the job. If I decided I wanted to be picking out more detail, then I either need to make the part bigger or use a smaller tool, and if I decide that the finish on it is too rough, then I would need to use a finer step over or potentially a smaller tool again in order to make sure I'm getting that combination of detail and smoothness. In this case I'm happy with the way this part looks, so I'm ready to go ahead and hit the next button again. And the final stage typically is where I would actually go ahead and save this, post-process it out for a specific machine. So it's possible with Machinist for me to directly save this toolpath now and send that to my CNC machine. I would just choose from the list here the appropriate post-processor for the machine and then go ahead and click on the button for finishing toolpath save. For our example though, we don't want to take this toolpath and send it directly to the CNC. We'd actually like to save the toolpath and then import it back into the other Vectric program in order to be able to position that and see it relative to other 2D and 2.5D toolpaths that we're going to calculate. So how we're going to do that is click on the button to save the V3M file for VCarve Pro or Cut 2D. So if we click on the button here, the software will automatically put a TP suffix on the end of the file name, but we can actually give this any file name we wanted. In this case, I'll leave it with the default, so the original file name fleur-de-lis b-tp, and the TP just indicates that it's got a toolpath in the file. So let's hit save. We'll overwrite the one that's already in the project folder, and at this point we've actually finished everything we need to do with VectorArt 3D Machinist. So I'm going to go ahead and minimize this, and we can come back into Cut 2D or VCarve Pro, whichever Vectric product we're working in, and import that toolpath data that we just saved as a V3M file. Within the software there isn't a specific import function for a 3D toolpath. We actually piggyback that off the import vectors function. So we come over to file operations and click on this icon here, import vectors from a file. And this will not only look for 2D vector formats such as DXF, DWG, EPS, etc. It will also look for the 3D toolpath formats that Cut 2D and VCarve Pro can import. In this case, you can see it's showing me the V3M files. This is our original V3M file from the website that doesn't contain any toolpaths. I would not be able to import data from that file if I tried to, even though it's able to find it in this open form. I need to make sure I select the one where we've calculated those toolpaths, either in VectorArt 3D Machinist or Cut 3D, and then save the file that contains those toolpaths specifically. So here from the project folder, I'm going to click on fleur-de-lis b-tp, and I'm going to hit the open button. When we import a 3D toolpath, two things happen. The first is the software generates this grayscale preview that you can see in the 2D view here, showing me the size and position the toolpath was calculated in VectorArt 3D Machinist or Cut 3D. This grayscale is actually something that we can select and move around in order to change the position that the toolpath is going to be cut within this part. As well as generating the grayscale, it also has added the toolpath to the toolpath list. So if we come over and click on the icon to switch to the toolpaths tab, I can see that in the toolpath list that was previously empty, I now have this toolpath called fleur-de-lis-F, and the -F shows that it's a finishing toolpath. If I was to have created a roughing, a finishing and a cutout toolpath, then it would have imported all three of those toolpaths and listed them separately. And as we have a toolpath in the list there, as long as this box is checked, we're also going to be able to see that in the 3D view. If we come over to the 3D view tab, click on that, and then if I just hold the right mouse key down and push the mouse away, I can zoom in, we can see that 3D toolpath that we calculated. So at this point I want to change the position of this toolpath to match the correct part of my sign where we want to cut it in relation to the 2D data. So I'm going to come back to the 2D view and I'm going to click on the icon here to switch to Drawing tab. So I'm going to come back over to the Drawing tab, and actually I think it would be useful to see both the 2D and the 3D view simultaneously. So I'm going to come up to View and Tile Windows Vertical. So now we have the 2D view here, the 3D view on the right. What I want to do is make sure that that toolpath preview is selected. So let me just click off for a second. If I click back on that, you'll see it becomes this kind of purple hue, showing me that it is in fact selected, and now I can use some of the vector editing tools in order to move that around within the part. In this case, what I want to do is put it into the same location as that circle we drew. So with that preview selected, I'm going to hold the Shift key down on the keyboard, click and select this circle as well. Now I'm going to come over and click on Align Selected Objects, and I'm going to choose this option here, which will horizontally and vertically center the first object I selected, which was the toolpath preview, with the second object I selected, which was the circle. So let's click on this icon here to center both. You can see that not only does that move the 2D preview, but it also moved the position of the 3D toolpath in the 3D view as well. So we know that relative to the other pieces in the part, that toolpath has now moved, and that's where it's going to be output and machined. Let's go ahead and hit close now. At this stage, I'm ready to start calculating my toolpaths. So from the 2D view control area of the drawing tab, I'm going to click on the icon to switch to the toolpaths tab. That'll minimize the drawing tab, and on the right of the screen here it will open up the toolpaths tab for me. You can still see my 3D toolpath there in the list. What I'm going to do before I calculate my VCarve toolpath, which is the next one that I want to create, is check my material setup. So I'm going to come up to the top of the toolpaths tab and click on the set button. So we can see here the values we selected when we did our job setup after we'd opened this part. Z0 is set to the top of the block, thickness of the material is set to 3/4 of an inch. And if you remember, it was extremely important that we matched those same choices when we set up the 3D part in VectorArt 3D Machinist. What is less crucial is the XY datum, the XY0 position. That can be moved around because, as you've already seen, we can move the position of the toolpath once we bring it into the 2D layout. In this case, we have it set to the middle of the job, and ordinarily there'd be no problem with that. Really, it's just personal preference as to whether you choose the middle or one of the corners as your XY0 position. For this particular example though, there is a reasonable argument why setting it to the center would not be a good idea. If we look, you can see the red square shows me where this position is in the 2D view, and that's actually within an area that's going to be machined away when we do our 3D toolpath. So if we were to machine this 3D toolpath first, then change the tool to do our V-carving, we would no longer have the piece of material here in order to touch off to set our Z0 for the tool that we'd changed. That's pretty important. Normally you want to set your Z0 off the same position each time. It doesn't necessarily need to be at X0, Y0, but that is fairly typical. So in this case, what I think I'm going to do is change to use the lower left-hand corner. And we can see that that now has been moved down to here. So my X0, Y0 position is actually going to be in an area that's not going to be cut by any of my toolpaths. Then it's just a case of setting my rapid gaps to be appropriate values. My home position, I'm just going to take the values we have set here and hit OK. Now I'm ready to calculate my next toolpath. So I'm going to go ahead and select the text from the 2D view. So I'm just going to click on the vectors for the text. Because that's still a text entity, I click on it once to select all of those objects. Then I'm going to hold the Shift key down on the keyboard and carefully select the inner and outer of these two lines that run around to make this decorative groove that follows the border. With those three sets of vectors selected, I'm going to come over, click on the icon to V-Carve, and I'm going to start at 0 on the top of the block, and I'm going to select a 90-degree V-bit from the tool database. So I'm going to just select 90-degree V-bit there, hit OK. I'm not going to select any of the other parameters here. I'm not doing a flat clearance in this. I want to do a true V-carve on it. So I'm just going to come down to the bottom and we'll change the name to V-carve and hit the calculate button. And then we can see that toolpath has been calculated. You can see after calculating that toolpath that the preview toolpaths form has automatically been opened. In this case, I'm going to preview everything once we've calculated our last toolpath. So I'm just going to hit close. I'm going to come over to the 2D view and select the outer border vector. I'm going to come over and click on the icon to create a profile toolpath. And in this case, we're going to cut out around that vector. So I need to start at 0 or the top of the material, and I'm going to cut all the way to the full depth of the part, 0.75 of an inch. I'm going to hit select and I'm going to choose a 1/4 inch end mill and go ahead and hit OK. So there we've got our 0.25 inch end mill, and in this case I might want to override some of the parameters for that tool. I'm going to hit edit and I'm going to change the pass depth for that tool to be 0.25 of an inch. I'm confident that I'm cutting soft enough material, for example, that I can be a bit more aggressive with that pass depth. And when we hit OK, you should see the number of passes we're going to take reduced by half. So if I hit OK, you can see that's updated, and now it's only going to need to go around that 3 times, cutting 1/4 of an inch deep on each pass in order to get through the full 3/4 of an inch of depth of material. Let's go ahead and change the name of this to Profile Cutout. Hit the Calculate button. I'm going to maximize my 3D view there. I can see my 3 toolpaths drawn in the 3D view. I can see them listed here in the toolpath list. Software's automatically opened the preview toolpaths form after we hit the Calculate button. And now it's a case of choosing the material that I would like to preview this in, and then working our way through those 3 toolpaths. So here I'm just going to go with the material that I have already selected here, Cherry, and I'm going to come down and click my first toolpath in the list, which is my 3D finishing toolpath. So make sure that is selected, click on the preview selected toolpath button, and there we can see that's been animated into the piece of material at the position that we moved it to. Next, we're going to click on the VCarve toolpath. I'm going to click on the button to preview selected toolpath, and now we can see that toolpath's been animated and shown the result of in the material here, so we can see how that's going to be VCarve based on the angle and size of tool that we've chosen. And lastly, I can click on the Profile Cutout toolpath from the list, click on the button to preview that, and there we can see the result of that last toolpath being shown in the 3D view. And if I want, I could remove my waste material in this case, because we've completely cut out around this and haven't left any tabs. I can just double click here on that part of the job, and that will just remove that material and show me what my finished part is going to look like. If we're happy with the preview, we're ready to save the toolpaths to send to the CNC. We could also save the preview image if we wanted to email that maybe to the customer so that they could approve what the finished part was going to look like. And you do that using the button here to save preview image, and then just choose which file format you wanted to save that as, JPEG or a GIF or something like that, that you could attach to an email and send. I'm happy with what I can see here. I'm confident I'm ready to cut this now, so I'm going to hit close on the preview toolpaths form. And I want to save these toolpaths generally in the order that I'm going to machine them. That's just normally the safest, most logical way to do it. So I'm going to select the first one, the 3D toolpath, and I'm going to go ahead and hit the Save Toolpath icon. So you want to double check that the toolpath that you've selected is in the list of toolpaths to be saved. If it is, then you just need to verify that you've got the correct post-processor selected from the list here. Post-processor is going to translate your file into a specific format that will work with your CNC. So you need to choose from here either your specific model of CNC or the name of the control software if you're using a third-party software like WinCNC or Mac3 or something like that. Once you're happy you have the right choice, the software will remember that, so typically you only need to do that once, the first time that you actually save toolpaths for your machine. Once you're happy that you've got the right toolpath and the right post-processor, click on the Save Toolpaths button, give the file a name, something appropriate that's going to help you remember which toolpath that is, for which job it is, maybe which tool it uses, and then you can hit the Save button. In this case I'm not going to save that. Then I would say I want to save my V-carving toolpath, so I'd select that from the list, check it's in the toolpaths to be saved area, click on the Save Toolpaths button, give that an appropriate name and save it, and then finally click on the profile, check that is in the right area here for toolpaths to be saved, click on the Save Toolpaths button, and again give that an appropriate name. At that point I should have 3 files on my hard disk that are ready to transfer to my CNC machine, either maybe over a network or using a portable or flash drive. Let's go ahead and just close the Save Toolpaths form. As well as individually saving my toolpaths to send to the CNC, I should also keep a safe copy of my complete project layout. This can be used for backup, it can be used if I need to make a change to the job, or it could be used as a basis for another job if I wanted to change the text or maybe change the 3D element that was being carved in here but still use the same basic sign layout. To save our job, I'm going to come up to File, I'm going to choose the Save As option, and in the project folder we're just going to save this and I'll call it Fleur Complete, and hit save. And so if you wanted to, you could open that particular file from the project folder and take a look at my exact setup for this job. So before we conclude, let's take a moment to summarize what we've looked at in this example. We started by opening a pre-designed border, showed you how to resize that, and then created some offsets to give us the vectors for the groove that we're going to machine and our overall profile cut around the outside of the part. We then generated a circle that indicated the position where we're going to put our 3D carving and generated the text for our 2D design. We then looked at the VectorArt 3D website and I showed you the place on the website where you can download the free VectorArt 3D Machinist software and also the sample files that you can download and work with in order to learn how that software functions. We created a toolpath, in this case just a finishing toolpath to machine our dished area, and then showed you how to save that in a way where we're able to import it into Cut2D or VCarve Pro. We came back then into the software, showed you how to import that 3D toolpath file, and then we went ahead and changed its position, aligning it with the circle that we generated, and then calculated the toolpaths for our V-carving and our cutout toolpath around the outside of our job in order to finish all the toolpaths we needed to create the sign. So you can see what a powerful combination it is, being able to calculate these 3D toolpaths in an external piece of software and then import them into VCarve Pro to complement them with toolpaths calculated within the software itself. It's worth reiterating that as well as using VectorArt 3D Machinist as we did in this example to calculate our 3D toolpath, you could also use Vectric's Cut3D software. Cut3D gives you more functionality, more importantly it also lets you import many other different file formats. So if you didn't want to use the clip art from VectorArt 3D, you could use Cut3D to calculate your toolpaths and then import them into VCarve Pro as we've done with this example. We'd recommend checking out the Cut3D trial software if you wanted to see the exact capabilities of the program. That concludes this video.